Now we will discuss scatter plots with plt.scatter. So a second more powerful method of creating scatter plots is the plt.scatter functions, which can be used very similarly to plt.plot function. Now let's start. So the difference between the primary difference of plt.scatter from plt.plot is that it can be used to create scatter plots where the properties of each individual point, such as size, face color, edge color, etc., can be individually controlled or mapped to data. Let's show this by creating a random scatter plot with points of many colors and sizes. In order to better see the overlapping results, we'll also use the alpha keyword to adjust the transparency level. RNG p dot x equals to RNG y equals to RNG dot color is equals to RNG dot red. Sizes is equals to 1000 RNG dot red. Now plt dot scatter x c colors s sizes alpha 0.83 sorry, c map equals to EIRIDIS. Now plt dot color bar now we can see here that changing size, color, and transparency in scatter points. So notice that the color argument is automatically mapped to a color scale, shown here by the color bar command, and the size argument is given in pixels. In this way, the color and size of points can be used to convey information in the visualization in order to illustrate multidimensional data. For example, we might use the iris data from scikit-learn, where each sample is one of 3 types of flowers that has had the size of its petals and sepals carefully measured. Now let's start. From sklearn dot datasets import iris load iris features iris now plt dot scatter features alpha 0.2. Now s is equals to features 3, c is equals to iris target, c map equals to VIRIDIS. Now plt dot x label iris dot feature names 0. Now plt dot y level rs feature names now. Now let's see. This will use point properties to encode features of the iris data. So now we can see that this scatter plot has given us the ability to simultaneously explore 4 different dimensions of the data. The xy location of each point corresponds to the sepal length and width. We got this. So yes, that's exactly the same. Yes. The xy location of each point corresponds to the sepal length and width. The size of the point is related to the petal width, and the color is related to this particular species of the flower. Multicolor and multi-feature scatter plots like this can be useful for both exploration and presentation of data. So now we will discuss plot versus scatter, a note on efficiency. Aside from the different features available in plt.plot and plt.scatter, why might you choose to use one over the other? While it doesn't matter as much for small amounts of data, as data sets gets larger than a few thousand points, plt.plot can be noticeably more efficient than plt.scatter. The reason is that plt.scatter has the capability to render a different size and or for each point. So the renderer must do the extra work of constructing each point individually. In plt.plot, on the other hand, the points are always essentially clones of each other. So the work of determining the appearance of the points is done only once for the entire set of data. For large datasets, the difference between these two can lead to vastly different performance. And for this reason, the plt.plot should be preferred over plt.scatter for large datasets.